Assalamualaikum warahmatullahi wabarakatuh. Today we're going to do lesson 4 on gears. So gears are going to be a rotating wheel-like device with teeth around its rim, and a gear train is 2 or more of these gears connected together. There are 2 main categories of gears. The first one is going to be wheel and pinion, which are gears that are in contact. In this case, moving one gear moves the other gear in the opposite direction. The next one is chain and sprocket. A sprocket is basically a gear teeth that fits into the chain or the links of a chain. And in this particular setup, they're going to move in the same direction. There are 2 main components to gears, namely the driving gear, which is also known as the driver, and the driven gear, which is also known as the follower. So the driver gear is where the input is happening. It's where we are putting in the effort. And the driven gear is the one that is turning because of the driver gear. So recall from the previous slide that this particular setup is called, hopefully you said chain and sprockets, and this particular setup is called pinion and wheels. So in pinion and wheels, it's going to move in the opposite direction, and in chain and sprocket, it's going to move in the same direction. So this particular drawing of the arrows is incorrect. It actually should be pointing the other way. So whenever you see a question on gears, the first thing I'd like you to do is label your driver gear and your driven gear. Whenever we calculated mechanical advantage of levers or inclined planes, we were looking at the numbers given to us with the simple machine. In case of calculating mechanical advantages for gears, I want you to be a little bit more careful. There's an extra step, and that extra step is that you have to calculate first the speed ratio. Then the speed ratio will let you know what the mechanical advantage looks like. A speed ratio is the relationship between the speed of rotations of a smaller gear versus the larger gear, or vice versa. Speed ratio is calculated when we divide the number of driver teeth with the number of driven teeth. A high speed ratio will mean that there is a low mechanical advantage and it's actually a speed advantage. A low speed ratio will mean that there is a high mechanical advantage, which is really a force advantage or a torque advantage. I do not want you to get speed ratios mixed up with mechanical advantages, so make sure that you understand they're 2 very different, distinct things. So there's a practice here on calculating the speed ratio of this given setup 1A. I'm just going to do it orally. I would like you to write it down and continue. If you would like to do it by yourself, then maybe pause this video and do it and then see if you got it right. It says here that the driver gear is going to be the larger gear, which is the 60 teeth, and the driven gear is going to be the 30 teeth. I want you to note that this setup is the pinion and wheel setup, and therefore they're turning in the opposite directions. Speed ratio, remember, is the driver gear over the driven gear, so it's going to be 60 divided by 30, which is going to give us a 2. High speed ratio means low mechanical advantage, and we're going to actually get a speed advantage. Anytime the larger wheel is going to be the driver gear, then I'm going to get a speed advantage. Anytime the smaller wheel is the driver gear, I'm going to get a force advantage. And that will become more clear as we do a couple of more examples. Our second example is this one. It says a small gear has 24 sprockets and a large gear has 48 sprockets. What is the speed ratio if the small gear is the driver gear? So small gear being the driver gear would mean that it's 24 over 48, which gives us a speed ratio of 0.5. Recall from our previous slide that a low speed ratio means that we have a high mechanical advantage. The second part, what is the speed ratio if the driver is the large gear? So it's again driver over driven, 48 divided by 24, which means a speed ratio of 2. Which gives you a greater mechanical advantage at what cost? So low speed ratio means greater mechanical advantage, which means that the smaller gear is going to be the driver. Which gives you a greater speed at what cost? The high speed ratio means the large gear is the driver, which means that low mechanical advantage, which is really a speed advantage. I would like you to watch this video. I'm not going to watch the entire thing with you, but I would like you to watch the entire thing. I'm going to play just the parts that I think are really, really important. The rest of it is also important, but I don't want to make this video too long. You can always Google it, or you can always come back to this PowerPoint slide and watch it.
If the big one is the input driven by my hand and the small one is the output, this is clearly a speed multiplier because the output is moving faster than the input. Switch it up. The drive gear is the small one. The driven gear is the big one. It's moving slower, so this machine multiplies torque. When analyzing gears, first, just play with the system. Then clearly identify which is the input, often called the drive, and which is the output, often called the driven. We'll need to calculate a ratio, and you can use either radius to radius, diameter to diameter, circumference to circumference, or often very conveniently, the number of teeth to the number of teeth, because teeth represent circumference. So 36 teeth to 12 teeth, that little one is spinning 3 times as fast, 36 over 12. That's a mechanical advantage of 1/3. Here's a 36-tooth, 24-tooth combination, which means that the little one is spinning 1.5 times as fast, and the mechanical advantage is 2/3. Remember that any mechanical advantage less than 1 is a speed multiplier, and a mechanical advantage greater than 1 in these cases is a torque multiplier. Note also the change in direction. If one turns clockwise, the other one turns counterclockwise, always with these enmeshed gears. Switch the input and the output, and you now have a speed divider. But more importantly, because it divides speed, it multiplies torque. So the output torque is going to be larger than the input torque. Mechanical advantage in this case, 36 over 24, 1.5. Now we're back to that 36-12 combination. Switch the input and the output, and you now have a torque multiplier. Clearly a speed divider identified visually, so it is a torque multiplier of 3. The mechanical advantage is 3. Note that a counterclockwise input gives you a clockwise output.
I want you to be very careful with this particular setup because when he talks about it, he's actually calculating the mechanical advantage. And the formula for mechanical advantage is opposite to the formula for speed ratio. So in his case, he's doing driven over driver if it's MA. The one that I have shown you in the previous slide, I have given you speed ratio. Speed ratio, driver over driven. Mechanical advantage, driven over driver. So be careful with that particular setup. So once again, high versus low speed ratios. High speed ratio, the advantage is that you create speed. Cost, it's hard to turn the larger wheel. You're going a lot longer distance when you're turning the larger wheel. Low speed ratio means it's easy to turn the smaller wheel. The cost is that you lose speed, but you get lots of torque or lots of force, meaning in other words that you have a high mechanical advantage. So what are some things that how can we manipulate gears to actually give us the combination that we need for the different needs that we have? So what are the changes in design that we could make? A really real world particular example of this is the science of cycling. So what does changing the gears on your bike mean? What is the best gear combination to use when you're riding up a steep hill? When you're riding up a steep hill, the best gear combination is going to be when smaller gear is driving a larger one, because that's giving you a force advantage. But if you're competing in a race and you need speed, then you need the larger gear turning the smaller one. So it's very, very important that you understand and can distinguish between the two ways to manipulate the gears. So if you want speed, your larger one will be the driver and your smaller one will be the driven. If you want force, then your smaller one will be the driver and your larger one will be the driven. All right, so that brings an end to our gears lesson. Make sure that you do the examples, the practice examples given to you in the practice booklet. Also, please make sure that you are ready for a quiz next Thursday. Next Thursday will be your quiz on topic lesson 4 on pulleys and gears. We will have a Google Hangout with Miss Asia. You will have it Thursday at 1 o'clock. And for Miss Lynn, I'm sure she will share it with you on her Dropbox or her Remind. All right. I hope you're safe and healthy. Inshallah. Take care. Assalamu alaikum wa rahmatullahi wa barakatuh.